Yeah, thanks, Kate, for that introduction. I'm always slightly nervous being the last person to speak in a lineup of people, just in case everything has been said or everything I was going to say has been said. But I think there's a little bit left to say. But I took the opportunity at lunchtime just to change a couple of slides because I wanted to say a little bit more about some of the things that people have been saying. I will say a little bit about some of the skills, but I also want to say, just to apply some of the science and some of the research to what we're actually doing at Kew at the moment. So there's this statement about, and this one actually comes from Dave Kendall in Australia, in Melbourne. They've been doing lots of work here. I think in many ways, Australia and parts of the USA are further ahead than we are. Certainly in Australia, they had a long drought around the early 21st century. And this statement really encapsulates, I think particularly where botanic gardens are at the moment. We can be quite nostalgic about clinging on to what we've got, but I think this statement very much says that, those days are over. It's now, change is inevitable, as it were. So many of you will be familiar with Kew Gardens. Over 300 years of history from and a very diverse treescape over 300 years. Change from royal palaces back in the Georgian days through Victorian 19th century, where it became very much more a national institution for plant science. Now it's also a very popular visitor attraction, over 2 million visitors a year. So it tries to do many things, and those things have changed over time. So it's very much an historic, what historians like to call a palimpsest, don't they? An overlaying of successive ownerships, influences, and also business objectives. But I think also as a botanic garden, as other people have said, I think Norbert mentioned this, it's also, we have to remember that the trees are not just ornamental and part of the landscape, historic landscape and the modern landscape. They are also individual botanic artifacts. They're also botanic specimens in their own right. And Kew has a few particular challenges. We have very, very poor soils, actually. People don't always realise that. Very free-draining gravel soils, quite a low rainfall, about 650 millimetres a year, which is not a lot, certainly less than some other gardens I've worked in. Obviously, the warming climate, but also the very high visitor pressure does have some challenges as well. So really the question for us is very much how are we going to adapt this treescape while retaining its distinctive historical values, but also as a botanic garden, how we can contribute to the knowledge of that process. And something I want to do quickly later on in my speech, just to talk about something we're doing, which is a landscape succession plan. It's a sort of an all-encompassing plan for both climate assessment of our species as they are, thinking about new ones, irrigation planning, and also adapting our arboriculture around those changes. So here's I slipped this slide in earlier on. Kirsten was talking about Stiphonolobium. We used to call it Sophora. I think I prefer the name Sophora. It's easier to spell, certainly. And this is a tree that was planted in 1762 when the garden was part of the Georgian garden, Princess Augusta, I think. And so it really just showed that, we've had trees that actually probably are quite climate resilient already. And, we shouldn't assume that everything we've got isn't. Some things are. But we're all talking about the negative aspects. I actually really enjoyed the lovely warm sunshine in the summer, but we did have 1 or 2 days when it got to 40 degrees Celsius, which is very, very warm for us in the summer, and we did actually lose some trees. There are a lot of trees that just looked poorly, but we did actually have quite a few deaths, and it's quite interesting. We've been madly recording what it was that died. His 2 species, Taxus cuspidata, the Japanese yew, and this is Notophagus menzesii, one of the small leaved evergreen Notophagus from New Zealand. And the interesting thing for me, and this is where we're hoping that Henrik will help us as well, is understanding what is it that killed them? Was it the drought, or was it the heat, or was it the combination of both? Is it the ability of trees to actually move water at a fast enough pace to keep themselves alive? And those are the sort of more subtle questions that we're hoping to answer through that process. Now, here's another example of our landscape. again, I think there's two things I want to say here. One is these historic landscapes. There's often, well, we often talk about part of the answer is going to be in diversity. Let's not put all our or too many of our eggs in too few baskets. But there's a tension there very often in that some of these historic landscapes and treescapes, landscapers were aiming at things that they used to describe as harmony and connection. They didn't want a bag of, one of each. They actually wanted big features that were single species, and sometimes that acts against that the diversity. So avenues are the classic here, but we're lucky in this particular avenue. Sion Vista at Kew is made up of holm oak. So we should remember that some of those species, holm oak's actually a hugely climate resilient plant. It comes from Southern Europe and will do very well in what we think is our projected climate. So, we should remember that botanic gardens in particular are already places that are very diverse, with plants that come from all over the temperate world, and they both have an intrinsic diversity, but also they have the potential for learning and informing the wider planting in less diverse places. So that's an important aspect. This is a different kind of landscape, maybe a more challenging one in some ways. There was a craze, certainly in the mid-19th century, to plant single genus collections. This was under Hooker and Bentham and those people, because they were scientists and they wanted more order. And this is an ash collection, for example, which is very interesting for understanding ash dieback and other things, but not necessarily so resilient, in the sense that sometimes single genus trees are not always may have not been planted in the best places, or they tend to share all the same diseases amongst themselves, which is not always a great thing. We've already talked about, so I just wanted a few slides now about the practical aspects of looking after the tree. We've already said quite a bit about the root zone. Absolutely key. We can't do that much about the climate, but we can at least give the trees that we grow the best possible chance. There's been a lot of debate about whether we should have long grass or no grass or short grass. I absolutely agree that short grass is probably the worst thing you can do. We tend to have taken the approach at Kew of mulching and keeping grass-free areas over, particularly what we think of as more vulnerable old trees. One of the snags with that, we try not to completely exclude people, because we understand that people like to get up close to trees and sit under trees. But this is quite a good approach. It stops perhaps the more casual, just people walking under them for no particular reason. But one of the things we've become have a better understanding of, not just the compaction from the number of people, but also there's always been a belief that mulching trees is good, so lots and lots of mulch must be even better. And it'd be interesting to hear what other people think about this. But there does seem to be a process of almost concretion over the years if you just keep on piling more mulch on. And actually, the danger is that you build up this hard layer, which is actually suffocating the roots. So it'll be interesting to hear what other people think about that. So this is some of the work that we do that Micah was talking about as well earlier on, measuring compaction levels. Also, sometimes tree spading, getting rid of that hard compacted layer and actually replacing it with something more, something lighter and more permeable. So that's something we do through air spading. Pests and diseases, we mentioned this already. We're trying to increase the monitoring we do on pests and diseases. I think it's true that the biggest source of new and novel and threatening pests and diseases is still globalization rather than climate change. But climate change is a potent sort of secondary factor. Things like oak processionary moth. This is treatment for oak processionary moth on the left. We now use Bacillus thuringiensis spraying. We used to use insecticides, and on the right is the Oriental sweet chestnut gall. So we're trying to monitor those. We treat them where we can, where they need to be, and certainly some pests and diseases like OPM, oak processionary moth, probably also box moth and others are hugely affected by climate change. And this is an example where we're trying to work with scientists to understand how we can control this. The Toomer sinensis is the parasitoid that parasitizes oriental chestnut gall, and we've been releasing this selectively at Kew and measuring the effect on controlling oriental chestnut gall. So that's an example of where we're trying to do something practical to help understand and control those things. I was interested in people talking about irrigation. Most gardens I've worked on over the years, it's not really been that much of an option, except for very young trees. Kew is quite lucky in a way that it is able to irrigate quite a bit, but there is a cost. So we're putting together an irrigation plan, very much with the intention of being much more efficient and effective in irrigation. Targeting, both in location but also timing, based on need, and that's something we're not very sophisticated at the moment. And soil moisture level meters is something we're also hoping that Henrik will help us with. Not necessarily the technology, but understanding the relationship between soil moisture level and stress in trees, so that we know when trees need it, so we can be much more focused. Zoning. This will go along with, as we develop new accession plans, is we maybe think about relocating the more drought intolerant species in irrigated areas, so not irrigating everywhere, because, and this is the last one, most sustainable, it's very, very expensive. We know we spend hundreds of thousands of pounds on water. That's irrespective of the environmental pressure. And being close to London, it's not a good look when everyone else has got a hosepipe ban and we're still watering, because, you know, so we're very, very conscious that it's not just about the plants. We need to be really efficient and effective on that. And I inserted this one, not a very great picture, I'm afraid, but what this shows is this is the kind of trees we plant. We grow them ourselves, generally, either from seed or from our own trees, and we tend to plant them small and we grow them fast. We hope to get very high ratios of soil to shoot ratios in air pots and get them into the ground quite young. And we feel that then, you know, they've got the best chance. They take less establishment time, and we do irrigate for certainly the first few years. Whether we will, you know, ultimately, it would be nice to think that once trees are independent in the landscape, we won't need to irrigate them. But, you know, that's a dream, really. So what I wanted to do from a practical sense is to try to translate some of that work that other people are doing on the science and the selection of new trees into actually what we're doing. We're all very familiar with these kind of scenarios, so I'm not going to dwell on that. And those tend to come from using these kind of climate projections from climate types from all over the world. This is the Copenhagen climate classification, to try, because Kew is a world garden, and as many of yours are, we already have plants from all over the world. So trying to predict what will do well, we do need to look at the kind of climates that those plants come from. One source of information we use, and again, I'm talking about this as a, you know, so because it's a very daunting thing. I'm sure many of you, we all know we're going to have to adapt, but how the heck do we go about it? Where do we start? This is the GBIF, the Global Biodiversity Information Facility, is quite useful. It's both for plants and animals, and it tells you where things are living at the moment, both in cultivation but also in the wild. And you can put in any plant you like. So if you look in this, I put in Acergrycium, the paperbark maple, and it puts a dot on a map all over the world where those things are growing. And you do get odd ones. I mean, Acergrycium is a Chinese species, so you've got a cluster here. But, you know, these are other places where it's successfully growing in the wild. And this, how do you then go about using this? I don't know if any of you were lucky enough to be at the BGCI Global Congress in Melbourne in September. One of the things I was excited about, I wasn't able to go, but one of the things I was really anticipating was the release of this climate assessment tool, which is a very simple tool. I mean, simplicity is a plus, it's also a minus, because, you know, any tool is going to be, you know, crude to some extent. But we've been using this tool, and what I wanted to do is just to describe where we got to with it. Again, this is based on a lot of the work that's been done in Australia, Melbourne in particular, and they've teamed up with BGCI to produce this tool. And this is something we're doing as the first part of our landscape succession planning. So you can see here, you start off by putting in, it's actually drop boxes. So there's a good chance your location will be on here or somewhere very close by. We've got Royal Botanic Gardens, Kew. This is just an example where I put in acuminatum, and then you can choose your climate scenario as 2050 or 2090. And then you hit the button at the bottom that then gives you an assessment. And this is what you come up with. So this is acuminatum based on the projected climate for Kew in 2050. And you can see there that actually things look quite good, really, using a variety of data sources, including the GBIF and others. Green is species most suitable. So that's good. That's the 12 degrees. So another one, we talked a lot about Fagus sylvatica today, and people said, oh, Fagus sylvatica hasn't got much chance of surviving. Well, if you put it in as 2050, you can see here for Kew Gardens, it's drifting into the 1s and 2s. But if you then go for the 2050 scenario, you can see the 2090 scenario, it's looking a lot more gloomy for Fagus sylvatica. And talking about Hendrik's work, we know, we're very big as well on, it's not all about species, it's about location, it's about provenance. And we're also interested in neonatives. So for example, for Fagus sylvatica, we're interested in Fagus orientalis. We're also interested in the naturally occurring hybrid between orientalis and sylvatica. I think it's called Torii. So those are the kind of things we're interested in. One word of warning, I mean, this is quite a crude, it's a question of granularity, really. And we're lucky at Kew. We've got people who are much cleverer than I am, who are able to add in more factors into this information, and particularly precipitation. There's all sorts of, seasonality, when the rain falls, how long dry seasons are, all those sorts of things. So this is very much a first cut, and this is what we're doing. We're also comparing data. It's very important, I think, that botanic gardens and gardens generally work together on these things. So this is one that shows an example of that. Sorbus anglica is one of these apomictic sorbuses native to Britain, grows in sort of wet western climates. So we know from this in 2050 it really won't do well here. But it's a rare species, and it's one that there needs to be a concerted, shared, collaborative approach to conserving in ex situ collections. And so by identifying that it's not really likely to do well with us in the future, we now work with other botanic gardens, including the National Botanic Garden of Wales, to make sure that over time, any plants that we have in our collections, are selectively, we make sure that someone else is growing these things and working collectively, so that that range of different climates, we can accommodate different species. That's an example of a species that we know probably won't do well. This is just an early assessment of our collection, which looks extremely alarming. Again, it's very much a first impression. You can see that we think that quite a lot of plants will do very well. There's a big area, 47%, where we really don't know yet. There's a level of doubt, and that's where a much higher level of assessment and granularity comes in. It depends on provenance, it depends on all sorts of things. So over the next year and the years, we will slowly refine that as we can. But we know that also, you can see the big red zone is trees. This is numbers of trees where we're pretty confident that they probably won't do very well in 2090 or 2050 even. And then people say to me, Simon, does that mean you're going to go and remove, you bad people are going to go and remove all 38% of your trees? And of course it's not. This is a projection, and I describe it to them as being like a hand on the tiller of a boat, really. We are going to push into a slightly different direction. And for the first few years, that we see almost no difference at all. And like being on a boat, over the years, we will slowly diverge from where we would have been if we'd done nothing. And in the context of tree planting, that means that we won't be simply slavishly replacing like with like. We'll be looking for alternatives, so that by 2050, 2090, we will have the garden landscape, treescape will have changed. But it's really having that plan rather than, just, and of course, botanic gardens particularly, and all gardens to some extent, we have always been pushing the bounds of what is, possible with the climate. If I say to people, if we can move from a position where 40-50% of the trees we're growing won't be surviving till 2050 to maybe 10% or 15%, that's job done, because that's probably as good as we ever really managed. Now, taking that to the next stage, we can then begin to look at, what's our landscape? What does our treescape look like? Where are the vulnerable trees? What's going to be the impact on that historical treescape I mentioned? If you can see, I don't know if you can see my cursor here, but this is Scion Vista I showed you earlier on. Those little green circles are all the holm oaks, Quercus silex. So it does work. It shows that that one is going to be fine. Other vistas are much more variable. There's much more doubt about those, but it gives you quite a nice initial spatial idea of the level of vulnerability and whether it's in patches. So you need to think about those areas of the landscape particularly. So that's interesting. One of the more interesting vistas I just pointed there is Pagoda Vista. This is very different and very unusual, actually. It's not really an avenue at all. And it was planted historically in the mid 19th century with matched pairs of broadleaf trees. That's its designation. So this gives us a really interesting opportunity to change the treescape as we go along and trial those new species without really, contravening or moving away from its historical intention, really. So, for example, here where we're removing very old red oaks, Quercus rubra, that really aren't doing very well anymore. We can bring in those new species that we're trialing. Kirsten gave us a very nice list earlier on, and certainly some of those trees will be on our assessment. But we're really at the moment we're not planting a lot of trees just at the moment. We are very much taking a year or two to develop new accession plans, new accession lists based on the research that we're doing. So we're not that worried whether we don't plant a lot of trees for the next 2 years. We're very determined that when we do get going planting again, we are planting the right ones. This is just a slide I put in. This was some work I did for the National Trust, actually, looking very much at the kind of thing that Norbert was talking about, substituting trees in an historic context, not really thinking about climate change so much, but it was done as much for pest and disease purposes. So Cedrus libani, many of you will know, is badly affected by Syrococcus sugae in many historic parks. And I just did an exercise just to try to illustrate an approach. The National Trust is very, very keen, and a very strong basis of a lot of what it does is the thesis of spirit of place, or genius loci, as the Romans used to call it. And just trying to think about what we would change those trees with. And I came up with these ideas. Is it purely imitative, or are we looking at trees that would do the same thing? Do they look the same? Do they serve the same landscape function? Is it a big evergreen? Is it a fantastic tree that flowers in the spring? Spirit of place, that's a bit more difficult to define, but it may be, for example, its particular time of introduction. Was it one of those classic mid-19th century trees that was collected by Ernest Wilson or, Hooker or somebody? So that was just a piece of work I did. It never got much further than this, but I think it's an interesting way of looking at things. So that is it. That is my slideshow of some practical things, but particularly what I was keen on doing is just showing that I know how people feel at the moment, many people, because I feel it too, this sort of sense of knowing we've got to do something, but feeling slightly daunted about what to do next. So this has really given us the opportunity to, really start that process of deciding what we believe will grow in our landscape in the future.